Hello, I'm Ursa Sadiq, Product Manager with Autodesk Plant Solutions. In this video, I'll show you how simple it is to reuse information that's in a P&ID drawing as you build a 3D model. You will see how to minimize data entry of line numbers, specs, sizes, and other information throughout a project. I'll also show you how to validate the model against the P&ID drawing so that you can eliminate any mismatches between them. Here I have a project that contains both a P&ID drawing and some 3D models based on that drawing. The piping model has referenced equipment, steel, and inventor parts. We're going to start in the P&ID drawing where we'll add a pipe and two valves. I'm going to zoom into this heat exchanger and tank so I can create a line between the two components. I'm going to select a line from the P&ID tool palette and start the line from the heat exchanger and go right into the tank. The program, of course, creates the nozzle I need. I'll then select the line I just created and click the Assign Tag button in the ribbon. In the dialog, I select a size of 8. I'm going to leave the CS150 spec, add service, and finally I'll enter a line number of 4,500. The Place Annotation checkbox is checked, so I'll click OK and place my line number annotation. This P&ID information will become part of my 3D model, as I'll show you later. I also want to add valves. I again click the tool palette, the Valves tab this time, and select a gate valve, and place it on my line. I'll select it and click the Assign Tag button again, and enter the number of 340. Remember this number as it'll come up again. I'll do the same to add a ball valve, click Assign Tag, and add the number 350. When I'm done, you can see I have a gate valve numbered 340 and a ball valve numbered 350. Now we'll switch from the P&ID workspace to the Plant 3D one, clicking the status bar to choose 3D piping. I'm going to go ahead and open up my piping drawing. And I'm going to create a pipe and valves in this 3D model using the line list to help me. I'll zoom in on the heat exchanger in the tank, and then open the P&ID line list dialog from the ribbon. In the list, I'll scroll down to find our line number of 4,500. If we expand this number, we can see the two valves, the ball valve and the gate valve. I'll select the line first and click Place to add the pipe to the model. This is a little crowded, so I'll dock the line list on the left and try it again. So again, I select the line, click the Place button, snap to the nozzle, and navigate to the end nozzle on the tank. If I look at the tooltip of this place line, I'll see that I get the P&ID information, namely the spec and service, automatically in my 3D model. Now we'll add the valves. I'll expand the line list again, select the ball valve, and click the Place button. I'll place it in my line and give it an orientation. Next, I'll repeat the process for the gate valve. Finally, I'll hover over each of these valves to show you tooltips. The information from the P&ID drawing has effortlessly appeared in my 3D model. If you take a look at these two valves, you'll notice that they're butt welded, not flanged. This is because the default valve in the CS150 spec is the butt welded valve. If the default was flanged, you would get flanged valves. You can also use the substitute feature to change these valves out to ones that have different end conditions. The substitute function is shown in a different video. Now we'll take a look at validation. In a perfect world, the P&ID drawing would be complete and final before the 3D modeling began. But of course, in the real world, timing is always somewhat overlapping, make it very easy to have mismatches between the two types of drawings. Here I'll right-click on the project manager and show you the validation settings. The first set is strictly for P&ID, the second set for AutoCAD, and finally a third set specifically to find issues between P&ID and Plant 3D, tag mismatches, items existing in one drawing and not the other, and so on. we'll test out the first two items regarding tags. I'm going to close the settings dialog and then run the validation process. The program checks each drawing and each reference drawing for any mismatches. The results appear on the validation summary. Depending on the size of your project and your models, this could take some time. You can see here that some drawings did indeed have mismatches, but not our piping drawing, which is not listed. I'm going to change one of the tags in our model and run validation again to show you how the process catches a mismatch. I'll change a tag in the gate valve from GA340 to GA999, and then run the validation again. Okay, here we go. Getting the tag dialog, changing its number to 999, and pressing assign. And rerunning the validation. You will expect to see the piping model listed with a mismatch. And wait for it. Here it comes. There it is. We see our piping model listed with a mismatch of model inline fittings. The gate valve tag was not found on the P&ID. To correct this error, all I would have to do is either change the P&ID tag to match the model or vice versa. As you can see, reusing information from a P&ID drawing in a 3D model is quite straightforward. I've shown you how you can save data entry time and also how to run the validation to correct any mismatches that appear. Thank you for watching.